first. A new self-tanning lotion for everyday use is to be sold. First, an experimental lotion mixture will be made. That's our prototype. By mixing 800 ounces of everyday moisturizing lotion with worth 80 cents an ounce with self-tanning lotion worth $2 per ounce. And that makes sense because the self-tanning lotion is going to be the more expensive variety. If the experimental lotion is to cost, they want to bring these costs down from $2 to $1.20. How many ounces of the self-tanning lotion should be used in the mixture? So do you guys get the problem down? Does that make sense? What they're trying to do is they're basically trying to take a pretty nice quality self-tanning lotion worth $2 per ounce, and they're trying to dilute it with this cheaper one that's just a moisturizing. I should give them the benefit of the doubt and say maybe they're not trying to dilute it, but they're trying to give it variety. It's not just going to be self-tanning lotion. It's also going to moisturize. That's pretty nice. Okay. Now I highlighted this as if it goes together, but in reality, this is the mixture. The mixture of the 800 ounces. So I'm using the highlighting kind of as a way to track what we're talking about. I'm going to do a table similar to the one we did before where it has a value equation in the end. The value is going to be made up of the different things like the moisturizing lotion, the self-tanning lotion, and then ultimately the mix. You don't have to use a table. I used to always draw pictures of cups, like bottles, one bottle pouring into a bigger bottle and the other one adding to that bottle to make the mix. I have started to think that this is probably one of the best ways to show it, though. This is the way your author demonstrates it. First, let's write down the type. I've already got that right here. I'll make that stand out a little bit. Then let's write down what we're dealing with. Each bottle is made up of a certain size of ounces and a certain cost per ounce. So I'll put the cost, and by that I mean per ounce, if I know it. Then I will put the size, if I know it, and that size in ounces. Make sure they're all the exact same unit type. They could have been tricky and given us one that was represented in pounds and one that was represented in ounces, and then we'd have had to convert them to one common unit. And then over here, this is going to be the value. So what's the moisturizing lotion going to cost you? $0.80. And it's already per ounce, so I don't have to write per ounce. And I'm choosing green to match my green up there. What's the size of the moisturizing lotion?
800 ounces.
First, an experimental lotion mixture is made by mixing 800 ounces. Oh, you know what? You are correct. That is correct. And so let me re-highlight this to match like I had before. That is the size of the moisturizing lotion, 800 ounces. What's the value of that bottle right there? Yeah, exactly. So the value is going to be the cost times the weight, or in other cases, value expressions when we get to the mixture problems where we have a solution and we have a percentage of copper or a percentage of some acid. Then it would be percentage times the weight, or times the mass. So in this case, we'll make our life easy, even though it wouldn't have been that hard. It's going to be 800 times 80 cents, so 0.8, and you get 640. Wow, that's crazy. 640 what? That is an expensive thing of moisturizing lotion. If that one's expensive, the other one's going to kill us, right? Just making sure I feel better about this. That seems like a large cost. But let's fill in what we have and then determine what we don't have and should still work out. Self-tanning lotion, it is $2 per ounce. Oh, and I wanted to go with blue. You can be colorblind. It doesn't matter what color you see. It's just whatever I wrote there. Do we know the number of ounces? No. Ah, good. So then we're not going to be able to figure out the value until we have that. Well, why don't we just call it something?
Okay.
I'll call it x2. So then what would be the value of that bottle? 2x. And you know that's a dollar amount when we're talking about value. Okay, so now let's come down to the mix. How much is the mix going to be? Okay, how many ounces? That's where when I used to draw a picture of two bottles pouring into a bigger bottle, that's where that was really helpful because you're thinking about the fact that I've got this bottle right here that's pouring in, and this bottle is going to add to it and pour in. They're great bottles, aren't they? Those are beautiful looking bottles. If this is 800 ounces and this is X ounces, can you tell me how many will be in the mixture? 800, not X. That would mean 800 times X. 800 plus X. That would be in the mixture. Does that make sense logically? You know, if you got this amount, it's going in and it's starting to fill a little bit up. You know, it fills up 800 worth. And then you pour this amount in, it's just going to add to whatever you were plugging in. So it'd be 800 plus X. Let's fill that in then. Now this also starts to trip a few people up. How are we going to represent the value there? Exactly, perfect. 1.20 times 800 times x. So you got to multiply by the whole thing. So you're not going to change anything. Up here we multiplied and we made that. Up here we multiplied and we made that. We're just finding the value expression by multiplying and making whatever we make. So multiply 1.2 times 800. I'll do that too. You get 960. Plus 1.2 times x. Kind of squeezing it in there.
So you just distribute it?
It's distributed. Yeah, exactly. It's going to distribute to both terms. Now, somehow this is supposed to help us figure out the answer to the question, which is ultimately asking about the mixture and saying how many ounces of the self-tanning lotion should be in the mixture. What was self-tanning lotion represented by? X, right? That was a self-tanning lotion. So all we have to do is find an equation where we can solve for X. Do you see one? This table just identified what we know and what we didn't know, allowed us to give a variable to the thing we didn't know. That's all been very helpful. But now we have to extract an equation. How about this? How about the equation that comes from this thing right here? There's an equation there, basically saying you got the value of the one bottle plus the value of the other bottle should equal the cost or the value of the third bottle. The mixture. So the value equation would be $640 for the first bottle, $2x for the second bottle. And once I know what x is, right, if x was 10 ounces, that would be $20, right? So 2x cost for the next one. It's supposed to make this cost for the final mixture. 960 plus 1.2x. That's the value equation. That's the one we can solve. Let's do your basic algebra. Subtract 640 from this side. I'll let this be the letter side. So I don't want those number terms there. And simultaneously, I'm going to subtract the 1.2x over here and the 1.2x over here. Don't be afraid of decimals, all right? That will knock out our numbers on the letter side. It'll knock out our letters on the number side over there. So here's the letter side. We get 0.8. 8/10 x is equal to 320 ounces. So then what do? Divide by 8/10 on both sides. And you said you get 400? 400 what? Ounces. This was representing, what was x representing again? The size of the self-tanning lotion. Good. This is the amount of our self-tanning lotion. Now, is this going to be a good or a bad situation for us? Let's look back and interpret. We hope it's a good situation. Are we going to need more of the expensive stuff or more of the less stuff? The less expensive. Here's the less expensive stuff, 80 cents, and we're getting 800 ounces of that. That's awesome. This is going to work out perfect because we'll use more of this. We'll bring the cost down ultimately for the consumer, but we don't have to use as much of the expensive stuff, so we increase our profit. Does that kind of make sense? So anyways, what I'm expressing there is you need to go back and interpret. Make sure that you answered what you thought you were supposed to be answering, and we did. Let me go ahead and plug it in. We'll see if we're right. Does that help at all? Could you recreate it? So you could build a table, and first of all, just don't even worry about the problem. Just start writing down everything that you know. That's a good testable question, by the way. Okay, if you want to do another one, let's do another one.